All right, for 1a, we have r equals 2 times 2 plus 3 sine theta. And gosh, this scale is going to be just times 2. So essentially, I'm just going to, I really want to just ignore that 2. How about we just ignore that 2 and just pretend like this is 2 plus 3 sine? Does that sound good? That sounds good. I'm just going to do a quick sketch of this. It's going to be up to 5 and then down to -1. So I know that this is going to have an inner loop. So this is a limacon with an inner loop. It's sine, so I know it's going to open up and down. So I'm going to just show you a bunch of shortcuts now that I didn't necessarily show you before because I don't actually think anyone's watching this. So, so sine, I'm going up a plus b. So that's 1, 2, 3, 4, 5. Okay, then opposite that, I will go a minus b, so that's -1, so that actually plots right there. Then I'm going to do side to side, 2 for those ones. Now I will just do 2 plus 3 times 1.5, so that's going to be some number that I can't think of off the top of my head, 3.5. So that's going to be here and also at 150. Then I'm going to do 2 minus 1.5, that's 0.5. That's going to be here and here. So 0.5 and then wherever this one is, 0.5, and then I have one at 0. So there is the complete graph for us. So basically what I did was a plus b, a minus b to help me find a bunch of them, and then a, and then I did a plus half of b and a minus half of b. All right, 1b is r equals 2 plus sine theta, so it's addition with just theta in there, so I know it's a limacon. And let's see, I like to graph these. It's going to be at 2, up to 3, down to 1. So this is going to be the dodgeball, okay? Because these guys are double each other, I know that this is going to be a flat-end circle like that. So let's use the little shortcut that I just did. I'm going to do 2 plus 1s, 1, 2, 3. It's going to go right there. 2 minus 1 is 1, and then I'm going to do 2, 1, 2, 1, 2 on the sides. Next we'll do 2 plus 1.5, so that is 2.5, and that's going to be here and here. Then I will do 2 minus 1.5, so that's 1.5. That's going to be here and here. Okay, so I will connect these guys right here to make that kind of flattish circle, and then loop it around. There you have it. Okay, 1c is r equals 1 plus 2 cosine theta. Okay, it's a limacon. Let's figure out which type it is. I'm going to have middle ground of 1. It's going up to 3 and down to -1. So it's going to be an inner loop, and it's cosine this time. So it's going to wrap around the x-axis. So I'll still use my little shortcut. I'm going to do 1 plus 2, so that's 1, 2, 3. Okay, then I'm going to do 1 minus 2. That's -1, so that's the opposite, but it's negative, so I'll put it in the same direction. Then I will do up and down 1. Now I'm going to use the 60s, but I will do half of that. So I'm going to get 1 plus 1. So that's going to be at this 60 will be at 2, and at this 60 will be at 2. And cosine's positive. Then we will do 1/2. That's going to be at 0, actually. So we're going to get this shape right here with the inner loop. 1d is r equals 5 plus 5 sine theta. So what I'm going to just automatically do is just say that my scale here is times 2 because I'm not going to have enough room on the one that I have here. I know it's a limacon because they're adding. I just need to figure out which type it is. So go 5 up to 10 down to 0. So this is going to be the heart. I also knew that because a and b are equal to each other. It's sine, so I know it's opening up and down. So I'm going to do 5 plus 5 is 10. Down here, I'll do 5 minus 5 is 0. Side to side, I just do a, so that's going to be 5 and 5. Next, we will do 5 plus 5 times 1/2, so that's going to be 7.5. That's going to be at the 30s, so this was 5, 6, 7.5-ish is right there, we'll say, and then jump all the way around to that one. Then we'll subtract, that'll be 2.5, so that's going to be at these 30s. 1, 2.5, and 1, 2.5. And there we go. We just draw it to make sure that we have that dimpled that touches 0, 0. And there's our heart-shaped limacon. 1e, r equals 3 minus cosine theta. That minus sign might trick us up a little bit, but all it's actually going to do is instead of the cosine graph opening this way, main way, it's going to open that way, the main way. But let's just see which type it is. I'm going to have a midline of 3, I'm going up to 4 and down to 2, and it's just going to start here at 2 before it goes up. All right, so that means when I do this over here, I can do 3 minus 1, that's 2, and then I add them. So I'll do 3 plus 1, and that will actually be this one over here at 4. Side to side is still going to be 3. Okay, then I will do the half. So 3 minus a half is going to be 2.5. That's going to be 1, 2.5 here, and also here. Then I will subtract it, but that really adds it, so it'll be 3.5. So that's going to be here, and then here, okay? Now, these guys don't equal 0, they don't go negative, so I know that it's the dimpled or the convex one. They're not double, so I know that this is going to be a convex one, and it's very difficult to draw this one, but I'm just going to basically draw it like that. There is technically right there, it probably goes in like that, but I just... we're good enough. All right, 1f, r equals 1 plus 3 cosine theta. Okay, so again, it's a limacon. We want to figure out which type it is, so I do that visually personally. So I'm going 1 up to 4 down to -2. So this is going to be an inner loop situation. It's cosine, so I'm going side to side with it. So let's do 1 plus 3 is 1, 2, 3, 4. Then I'm going to do 1 minus 3 is -2. So that's from here, -2, plots it over here. We're going up 1 and down 1. For cosine, we'll do the 60s. I'm going to do a half, so that's going to be 1 plus 1/2, so that's going to be 2.5. So 1, 2.5, and then 2.5. Then I will subtract it, so it'll be 1 minus 1.5. That's actually negative. So when I'm here, I'm actually going to be... when I'm here, I'm going to be -1/2. It's going to be in here. And when I'm here, it will be, I'm doing this weird here. It will be -1/2. Sorry, I was doing these two angles. Got myself a little confused. I know at some point it has to equal 0 if it goes negative. So I'm going to have this shape right there. Okie dokie, 2a. We have r equals 5. I'm just going to distribute this through, -5 sine theta. Okay, so I will just do a quick sketch of this. I got 5, I'm going up to 10, down to 0. So this is going to be a heart-shaped one. It's a negative sign, so I'm going to end up going like that when I graph this. But realistically, sine opens up and down. Negative means it's going to just open down. So when I do this, my scale is going to be times 2, okay, because otherwise I can't get to 10. I'm going to, let's see here, what is this going to be? It's going to be up here, it would be 10, so it's actually going to be down there, -10, sorry, when we doing these things. This is going to be 0. There we go. My bad, I kind of explained that wrong. Let me try that again. I add these together when I'm at 90, so that's 5 minus 5 is 0. When I subtract them, that's 5 minus a -5 is 10. Down there, side to side, I'm going to be at 5, so that's 2.5, 2.5 with the scale of that. Next, we will do, when sine is positive in these two quadrants up here, we're going to be putting in a half, so that's going to actually shrink it down to 2.5. So I'm going to be 2.5 with a scale this is really annoying, by the way, but oh well. I'm going to get that and that. For these two quadrants, I'll put in a -1/2, which makes it positive, so I'm going to be at 7.5. So 1, 2, 3, 4, 5, 6, 7.5. That sounds good, don't you think? There we go. And this one actually looks like the real heart one because of the way that it's facing. So exciting. To be or not to be, that is the question. Ugh, what ugly numbers I picked here. All right, we know it's a limacon because it's addition with a theta in there. My midline is actually down here at -1/2. I'm going up 1, which is going to bring me to +1/2. Gosh, this scale is awful. And I'm going down here to a -1.5. Oh boy. So it's negative sign, so it actually starts and it goes like that. This is going to be tricky. I feel like because this is so small, I'm going to use the pen instead. So when I add these together, I'm going to get a -1.5. So when I'm at 90, I'm actually going down here to -1.5. When I subtract them, I'm going to get a +1/2, which is going to go in the same direction. Side to side, we're going to be at a half and a half. Really -1/2, but when I'm at this side, it will plot that point. When I'm at this one, it will plot this point. Next, we need to do our you know, a plus half of b, so I'm going to have negative 1/2 minus a 1/2, so that's going to equal a negative 1. So when I'm at this angle right here, I'm actually plotting a negative 1. Same thing over here, plotting a negative 1. Then I will do a negative 1/2 minus a negative 1/2, which is going to actually be plus. That's going to be 0. So this gives us an inner loop, and there we have it. I don't know how good you can see that, but 2c is r equals 4 minus 3 sine theta. Our scale, again, is going to be times 2. So let's figure out which type it is. My midground is at 4. I'm going up to 7 and down to 1. So this is going to be either dimpled or the dodgeball. It's not the dodgeball because they're not double. It's sine, so it's opening up and down, and it's negative, so I know it's actually going to be mainly going down. So let's figure this out. When I do 4 minus 3, it's going to be doing a scale of 1. That's in the wrong spot now. That's unfortunate, but oh well. 1. When I'm down here, I will subtract them. So a 4 minus a negative 3 is going to be 7. So this is 1, 2, 3, 4, 5, 6, 7. Side to side is going to be 4. Okay, then I will be doing 4 minus 1.5 for these two guys. So that's going to be whatever that is. I don't know. Math is hard. 2.5, something like that. So it's going to be like right there and like right there. Then I will do 4 plus 1.5, which is going to be 5.5. That's going to be for, I don't know, that's like right there-ish. We're not perfect here. All right, so there we go. There's our shape. It does not touch 0, but it has that slight dimpled shape going on there. We got our first spiral, r equals 3 theta. We're definitely doing this in radians. And I will pick a scale that's ginormous, times 5, because that 3 is going to make us go out really fast normally. And I think I'll just make a quick table of values here. So I'm going to do 0. Let's see, what other angles can I do? I want to make sure that it's nice angles that will work nicely with this one. Sorry, it's actually way easier to pick the angles than the radius. I don't know what I was doing there. I think I said I was doing the angles, but then was writing the radius and I confused myself. All right, here we go. So plug this in, 0, we get 0. Here we're going to get 3 pi over 2, and I'm just going to pretend like pi is really like 3. Don't tell anyone. So this is really 9/2, so that's 4.5. When I do this one, this is going to be 3 pi, which is approximately 9. Here I will get, what is this? 3 times 3 times 3, 27 over 2-ish, give or take, so that's like 13.5. It's really 9 pi over 2, I believe. Then here I will get, that's 6 pi. Math is getting really hard at this point, which is approximately 18. So when I jump over here and I go to graph these, I start off with 0, 0. When I'm at this angle, I'm going to be at 4.5. Scale is 5. When I'm at this angle, I'm all the way out at 9. When I'm at this angle, I'm at 13.5. So this is 5, 10, 13.5. Sounds good right there. And 2 pi is going to be 5, 10, 15, 18, give or take right there. So here is our spirally shape. 1e, we get r equals 2 sine theta. So this is a circle or a one petal rose curve, depends on how you want to think about it. So I'm going to think of it as a circle. I recognize it as sine, so it opens up. It has a diameter of 2. So this is going to be a circle with a diameter of 2 opening up. Done. 1f, r equals 6 cosine theta. So I recognize this also, one petal rose curve, aka circle. It's opening in the x direction, has a radius of a diameter of 6. So I have to change my scale here to be times 2 because I don't have enough room. And I'll have 1, 2, 3, 4, 5, 6, and we have a circly shape right there. Ta-da! 3a, r equals 2 over sine theta. So we recognize this one as the line, but let's just convert it to rectangular. Our sine is really y, so this is y equals 2. Y equals 2 is a horizontal line at y equals 2. Ooh, I tried to trick you with 3b. We have r equals 4 over cosine theta minus 4 sine theta. So I'm going to multiply that to the other side. R cosine theta minus 4r sine theta equals 4. R cosine is x, R sine is y. And I'm just going to use a shorthand that I learned a long time ago, so I'm going to do x equals 4, 1, 2, 3, 4. Then I'm going to do y equals -1, okay? And there is the line. 3c, r equals 6 sine 4 theta. Recognize this as a rose curve. It's going to have 8 petals. Each one then is going to be whatever 360 divided by 8 is. I think that's 45. The max r value is going to be 6. That means I need to change my scale to oh my goodness, to times 2. I need to figure out where to start. So it's sine. Sine normally starts at 2 pi. Can't talk today. Pi over 2. All right, so this is going to be theta equals pi over 8. So that's going to be these kind of halfway marks here, the ones in between the 45s like we were doing at some point in one of these crazy lessons. So those are all the points that I'm going to do with a max radius of 6, which in this case is going to show as 3. So I'm going to do 1, 2, 3, point, 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 and then boop, 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 boop. Done. 3D, r equals 8 cosine 6 theta. Wow, that's going to be a 12 petal rose curve. And we're going to do 360 divided by 12. That is going to be 30 degrees away from each other. Our max radius is going to be 8, so I'm going to change the scale to b times 2. You need to figure out where it starts. It's cosine, so that makes life easy. 6 theta equals 0. Theta equals 0 will be our starting point. I'm going to use the pen because otherwise this is going to get a little bit crazy. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm literally just going to go every 30. And that's going to give me every last one of these. You would graph these a lot neater, obviously, in real life, but I'm getting tired, so getting messy. Alrighty, we got, let's see, 3e is r squared equals 5 cosine 2 theta. So the r squared and the 2 theta give this away that this is going to be a 2-petal rose curve situation. That means they're 180 away from each other. The max radius is going to be the square root of 5. That's annoying, but oh well. And we need to figure out where it starts. It's cosine, so 2 theta equals 0. Theta equals 0. So that means we're going to find wherever the square root of 5 is, a little bit bigger than 2, go 180 away, and draw my 2 petals. There we go. We are donezo. 3f, we have r squared equals 7 sine 2 theta. Okay, so this is going to be a 2-petal rose curve where they are 180 degrees away from each other. Max radius, square root of 7. Who has any idea what that is? The starting point, it's sine, so we'll do 2 theta equals pi over 2 when sine normally has its first maximum. So that's going to be theta equals pi over 4. Okay, so let's see, square root of 7, that's bigger than 2 but less than 3. So that's right there, and then I will just go in the opposite direction, and here are my 2 petals, and there we go, that's the graphing stuff. Okay, for this matching one, I'm going to try to isolate the different equations and graphs. So when I'm looking at these, I always like to start with circles. So those are the easiest. So when I look up here at all the equations, the only circle one I see is right there. And this makes sense. It's negative cosine, and this circle is going in the negative x direction with a diameter of 4. So this one has to be 3. Next, I would look for any lemniscates. Okay, so there's a lemniscate right here. That's going to be an r squared equation, and it's the only one, so I know that this one has to be 9. Next, what I like to look at is all the different rose curves that are on the graph. Okay, so rose curves are the ones that don't have any addition and subtraction in their equations. Okay, I feel like I missed one. There we go. All right, so if I was looking at these ones, I would start with the 3-petal rose curves first. All right, and I know that this one's going to have 3 theta, so this one 3 theta. This one has to have cosine, this one has to have sine. Cosine always wraps around the x-axis. So when I'm looking at these, this one has to be 8. Okay, this one right here is going to be 11. Next, I would look at these two that have the 4 petals. So when there's an even number of petals, it's always 2 theta on the inside. This one down here has to be sine. This one has to be cosine. Cosine always wraps around the x-axis. So this one right here has to be 2, and this one down here will have to be 12. And that leaves us with this one. There's 1, 2, 3, 4, 5, 6, 7, 8 petals. So I know it has to be 4 theta and a cosine. So it makes sense that this one has to be 5. So that brings us to our Limacues are limaçons, if we're being all fancy and French and stuff. And so that's all the ones that have addition and subtraction in it. Okay, so that's all of those ones. And if I was starting off, I would look at these two right here, which are going to have A equals B. So whenever we get this heart-shaped where it touches 0, 0 there, then we know that it's going to be A equals B. This one has to be a cosine, so it's going to be 6. This one down here will be sine, and it actually will be negative because it's opening in the opposite direction up top. So it goes in the negative direction, so it has to be 10. Next, I would look at this one right here. I know when it has an inner loop that means that the A value is going to be smaller than the B value. So when I'm looking at these, that's going to only be this one, and it makes sense. We have a negative cosine, it's opening in the negative x direction. So I know that this one has to be 7. So that brings us to these two. This one opens around the x-axis, so it's going to be a cosine, and it's negative because it's opening more in the negative direction. This one will be positive sine because it's opening in the positive sine direction. And I also know that A is going to be bigger than B in both of these situations. So this one over here will be number 1, and this one over here will be number 4. Yay! So when we're given a graph of a polar equation and we want to try to find that equation, we want to first identify which type it is. So when I'm looking at this, I recognize that this is going to be a limaçon, or limacue as I like to call them. So that's equation, the equation for these are r equals a plus or minus b, and then either sine or cosine of a single theta value. So when I'm looking at this one, I know that it actually is going to be sine because it wraps itself around the y-axis, and I also know it's going to be positive. So what I really need to do here is figure out what a and b are going to be. And there's a couple different ways we could go about doing this. One way is to try to sketch an approximation of what this is using some of these points here. So the max radius is 1, 2, 3, 4. So I know that this thing's going to reach a maximum of 4. And when we have this inner loop, that means the negative radius. So I have a negative radius of negative 2. So I want to figure out what's halfway in between these. So this is 6, so it's 3 up and 3 down, so it's going to be 1, and that also connects to those points right there. So I now know exactly what this is. I already know it's sine because it wraps itself around the the y-axis, and it's positive. So I know that this is going to end up looking like that, but really all I need to know is this. The 1 and then the 3 that we go up and down. So this is going to be 1 plus 3 sine theta. And we were able to do that by just identifying some common points here that basically correlate to our critical points when we're graphing sine. For part B of this one, I recognize this as a rose curve. So rose curves have the equation r equals a, and then either sine or cosine, n theta or k theta. I never remember which letter I like to use. Some shortcuts that we can use to help us figure some things out is if it wraps itself around the x-axis, we know it's going to be cosine. This a value is the maximum radius. So if I look 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, all of these petals have a max radius, max r of 3. And we also know that whenever we have a rose curve going on here, that the n value, if it's even, will have twice as many, and if it's odd, it will have that exact amount. So there's 1, 2, 3, 4 here, so that means that our n value is going to have to be 2 in order for us to end up with 4 of these petals. So that gives me r equals 3 cosine 2 theta. All right, for question 6, we're trying to find the intersection of two polar graphs. So I'm going to start off with their equations here, and I'm just going to set the r values equal to each other. So I get 2 minus 3 cosine theta equals cosine theta. That will give me 2 equals 4 cosine theta. So cosine theta is going to equal 1/2. That's going to be in quadrants 1 and 4, and a reference angle of 60. So I'm going to have theta equals pi over 3 and 5 pi over 3. And then I'm just going to take this and plug it back into one of the two equations. I'm going to plug it into this one, and remember that I know that at these angles it equals 1/2. So I just know my radius is going to be 1/2, so I get 1/2 pi over 3 as one point, and 1/2 5 pi over 3 for the other point. Okay, 6b, same thing. Just going to set these equations equal to each other, so I get 3 sine theta equals 3 cosine theta. I'm going to immediately get rid of the 3's and I'm going to divide. So I'll get tangent theta equals 1, sine over cosine equals 1. Let's see, that's going to be in quadrants 1 and 3 with a reference angle of 45. So I'm going to get theta equals pi over 4 and 5 pi over 4. Now, neither of these are actually up here, so I am going to have to do a little bit of math. I'll just pick the sine value. Sine of pi over 4, that is going to be square root of 2 over 2. So I'm going to have a radius of 3 square roots of 2 over 2 for pi over 4. And for 5 pi over 4, I'm going to get negative. Okay, so it'll be negative 3 rad 2 over 2, comma, 5 pi over 4. And these are the 2 points of intersections for these graphs. 6c, just start off same way, setting them equal to each other. I've got 4 cosine 2 theta equals 4 sine theta. I'm going to just get rid of the 4's altogether, use my identity sheet to replace this cosine 2 theta. There's 3 different ones I could use. I'm going to pick the one that has all sines because I already have sines. So I have 1 minus 2 sine squared theta equals sine theta. I'll get everything to one side. So that's going to give me 2 sine squared theta plus sine theta minus 1 equals 0. And then we just got to factor this. So I'll start off with knowing that, 2 sine theta and sine theta have to do that. 1 has to be that. Whatever 2 multiplies by needs to be positive because the middle term is positive. So that allows me to very easily factor this and get that sine theta equals 1/2 and sine theta equals -1. This guy is going to be in quadrants 1 and 2, reference angle of 30. So I'm going to have pi over 6 and 5 pi over 6. Sine theta equaling -1 is going to happen at, what is that, 3 pi over 2. Okay, now I'll just take these and plug them back in. I'll plug it into here. So for these first 2 angles, I know sine will equal 1/2. 4 times 1/2 is going to give me 2. So I'll get 2 as a radius, pi over 6, and 2 5 pi over 6. When I plug in 3 pi over 2, I'm going to get a -1 times 4, so I'm going to get -4 for that radius. And these are the 4 answers. 3 answers. Ugh, counting's hard. Magically skipped number 7 in my answer key, and on your notes, I'm assuming, unless I've renumbered things, but I have find the values of theta between 0 and pi that form the portion of the graph r equals 5 cosine 3 theta in quadrant 3. So I'm just going to quickly sketch a graph of this. So I'm going to first start off with the period is 2 pi over 3. Remember, we divide by the b value. X scale, we take that and we divide it by 4. So I'm going to get pi over 6. So when I graph this, I will get something like this. So that's pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and 6 pi over 6. So I know that I'm stopping right here at pi. And I do like to label some of these ones, so I will just throw in a little pi over 6 for this. This is 2 pi over 6, 3 pi over 6, so that's pi over 2, 4 pi, and this is 5 pi over 6. Okay, so the reason I like to do that is because this is going to allow me to figure out what's going on here. So if I do this back in a polar graph, this first little part right here, that's going to be in quadrant 1. Okay, so I know that this is in quadrant 1 because positive radius with angles in quadrant 1 stay in quadrant 1. For this section, the angles are in quadrant 1, but it's a negative radius. So this is going to bump down to quadrant 3. So for these guys right here, they're actually in quadrant 3, and that's actually going to be my answer. I'll be done, but we'll just keep explaining. From pi over 2 to 5 pi over 6, positive radius, so that's up here. We're going to stay in this quadrant. From 5 pi over 6 to pi, so that's this little part, we're going to reflect to the opposite side, and this part will be in Q4. So we really don't need to actually sketch a graph of what this looks like. I mean, if you want to know, it's something like that. They should all be the same length. I'm just terrible at drawing. But I know the answer just from this graph over here, that it's going to be pi over 6 to pi over 2, that this graph will be in quadrant 3. All right, for 9, we're trying to find values of theta between 0 and 2 pi that form the inner loop of the graph square root of 2 plus 2 sine theta. So I know that the inner loop is formed when it goes negative right here. So basically when we have negative r values, okay? So I'm just going to set r equal to 0 to figure out where this point is and this point is right there. Okay, so I'll just subtract and divide. I'll get square root of 2 over 2 equals sine theta. So that's going to be in quadrants 3 and 4 with a reference angle of 45. So I'm going to get theta equals 5 pi over 4 and 7 pi over 4. And I know that's just going to be between those, so I just rewrite that as an interval. 5 pi over 4 less than theta less than 7 pi over 4. Ta-da! Math. All right, for these advanced graphs, what we want to do is first figure out which one of the two equations it's going to be when we're looking at it. So the absolute value ones look like rose curves, which means they have to connect to 0, 0. So this one right here, I'm suspecting is going to be an absolute value one and not actually this other type. So if we go under that assumption that this one is the absolute value one, there's 1, 2, 3, 4, 5, 6. So for absolute values, the inside of the equation, this k value, is always half of the number of petals. And then the a value is the max radius. So this is 1, 2, 3, 4, 5. So I know that this one's going to be the absolute value of 5 cosine 3 theta. Now for these other ones, what I'm going to do is, I know that it's going to be this equation here, and my goal is to basically figure out what a, b, and k are going to be. For this type right here, I know that k is always going to be equal to the number of petals that there are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I also know this one's going to be cosine because it wraps itself around the x-axis. So I can start off with r equals something, something, cosine 10 theta for this one. So my goal is to figure out what that something is. And what I can use is where these max radiuses are and where the minimum radiuses are. So this one goes out to 5 and 3. So if I were to translate that to the traditional cosine graph, up here at 5 and down to 3, I know the midline has to be at 4 and it has an amplitude then of 1. So that helps us write the equation. A is the midline and we have an amplitude of 1. Done. When we have these guys, we know we're going to have negative radiuses when we have the little itty-bitty petals that are going on here. And I know that when it's odd, like this, they go inside, and when it's even, they go outside. So the number of big petals is going to be what the k value equals. So I know this one is going to be cosine because it wraps around the x-axis. So I'm going to have r equals something, something, and it's going to be cosine 3 theta. This one is going to be a sine because it does not wrap around the x-axis, and there's 1, 2, 3, 4 big petals. So I'm going to have r equals something, something, sine 4 theta. So to figure out what those something somethings are in each one of these, I'm going to do the same thing we did over here. I'm going to just sketch a quick graph, and my big petals go 1, 2, 3, 4, 5. The little petals are 1, 2, 3, but they're negative. So that's really important. So I'm going to go down here, negative 3. Okay, so that allows me to figure out where my midline is. There's 8, so that's halfway is 4 is 1. Okay, so my midline is going to be at 1, and my amplitude is 4. And that will give me this graph. Do the same exact thing down here. We have 1, 2, 3, 4, 5 for the big petals, and 1, 2, 3, so it's negative 3 for the little petals. So it's going to be the exact same thing. 1 is the midline, and 4 is the amplitude. So I'll have 1 plus 4 cosine 3 theta. And there you go.